All right, let's jump right in. Today, we're looking at something totally wild, an explainer on the Philfo hypothesis. This is a highly theoretical, incredibly ambitious framework that blends speculative cosmic alignments, acoustic physics, and absolutely massive macro engineering. The goal? Solving an impending global water crisis. It is dense, it is provocative, and we're going to break down exactly what these authors are proposing. Here is our roadmap for today. We'll hit the 2026 climate threat, the Happy Earth model, designing reversible rivers, global supply chain integration, the 4th and 5th urban supply, and finally, tankies and local harvesting. Section 1. The 2026 climate threat. To understand the solutions, we obviously need to look at the threat first. The authors are essentially sounding a massive red alert for the year 2026. The source material warns of an impending super El Niño event starting in June of that year, which they say will act as a catastrophic threat to global hydrology and agriculture. We're talking severe drought and systemic collapse if it goes unaddressed.
But it's not just El Niño. The model points to a cascade of regional threats, like a collapsing polar vortex that could trigger a localized mini ice age in the northern hemisphere. It also highlights localized health outbreaks, specifically 27 recent cases of hepatitis A and jaundice in Patiala, Punjab. Now, the authors don't just see this as a local plumbing issue. They identify this outbreak as the early resonance, the IS point, as they call it, of the total stagnation and failure of the Gugger-Hocker River system.
Section 2. The Philfo Happy Earth model. So, how do we fix it? The core of this Happy Earth model is the immediate need for a massive, closed-loop hydrological infrastructure. The objective is to capture river water in emergency ponds and subterranean tunnels before it discharges into the saline sinks of the Arabian Sea and the Bay of Bengal, harvesting what the authors call Philfo grace particles to maintain planetary health. And here's where it gets really interesting. According to the hypothesis, you can't just move this water using traditional pipes. You have to treat it vibrationally. The core tool is Reversible Cymatics. Essentially, by using acoustic alchemy and vibrational metrics, we can theoretically harmonize these multidimensional energy and water flows, purifying the water without actually changing its chemical ingredients. Section 3. Designing reversible rivers. Let's look at the physical infrastructure of this. So the hypothesis proposes a radical re-engineering of the Earth's waterways. Look, in our natural set of solutions, we have rivers that flow downward from the mountains to the sea, right? Well, the authors propose pairing these with special rivers. These would be engineered pipelines and tunnels forcing seawater inland, spreading it from the sea to different parts of the Earth. Imagine a natural river going one way and a specialized engineered river bringing seawater deep into arid lands going the exact opposite way. By doing this, we can regulate and manage both the coming and going water supplies, ensuring regular, balanced, all-time water availability almost everywhere. And the authors point out that brackish water benefits become a huge blessing here. By using these opposite water flows, we can optimize tidal barrages, leveraging water density differences and their 5D approach with cymatics. Plus, because seawater is constantly sitting in these inland channels, they could literally function as massive sea salt water battery systems. And these reversible rivers are super adaptable. Think about rainy days. When the rain hits, you just stop the incoming seawater. The empty sea-to-land channels can then accept all that excessive extra rainwater, storing it in lakes, ponds, and dams. The text notes that clouds would naturally accompany both the mountain and sea streams alike. And here's the wild part. When the mountain river and the stored rainwater meet in these channels from opposite directions, it theoretically creates massive churning, vortex spiral, and spin dynamics. We're talking giant Philfo fountains that naturally purify the water. Section 4. Global supply chain integration. The ambition here goes way beyond just moving water. The authors propose using these specialized channels as multi-purpose global supply corridors. You could run crude oil, petroleum, and natural gas pipelines right alongside or within these same structural pathways. Add in global internet and telecom cables, and suddenly you have incredibly efficient link rivers spanning massive distances, drastically reducing global infrastructure costs. Zooming out, the authors compare the entire Earth to a massive, self-recharging biodynamo. By creating these closed loops of water and energy, they believe humanity can stabilize the physical Earth and integrate with broader cosmic energies through these newly interconnected link rivers. Section 5. The 4th and 5th urban supply. Let's get down to the city level. When these link rivers reach a city, the water supply splits. You get two initial supplies, one for sanitation and one for drinkable water. Now, the drinkable water eventually flows into the sanitation system, creating your sewage output. This yields three distinct streams: drinking, sanitation, and sewage, which then merge into a fourth hybrid flow. This fourth flow is filtered, recycled water sent out to local branches for gardening and farming. But the real magic of this urban design is the fifth element. The hypothesis proposes creating decentralized mixing, purifying, and filtering pools in different parts of the city. This fifth water supply uses that theoretical water vortex, spin and spiral churning, to filter the hybrid water from the previous four streams using reversible cymatics. Once purified by this churning, the water goes back into the main link river or its local branches. Section 6. Tankies and local harvesting. Down at the residential level, the model proposes a dual tank system, colloquially called tankies. Residents would have one specific tanky dedicated to pure drinking water and a second tanky strictly for sanitation and washing clothes. Crucially, that second tank acts as a collection point for local rainwater and floodwater during storms. Residents can pump water to their individual or community tankies, allowing local authorities to step in and manage flows during serious flooding seasons. And get this, the source text offers a truly fascinating practical application. Because these engineered sea-to-land rivers are bringing seawater inland, they suggest that water tankers from the sea can literally be used for cleaning sewage, sanitation, and even rinsing your clothes in the initial stages of the project. The ultimate vision is a globally interconnected, crisis-ready society. By managing the flows between these reversible rivers, tankies, and other storage systems, we could link regions all over the world. We're talking Patiala City, the city of gardens in Punjab, connecting with regions in North, South, and Western Australia. We're talking the American West Coast, like Arizona, California, and Oregon, up into British Columbia and Canada, and all the way over to Japan. And what's absolutely staggering is that these very research reports were initially submitted to the Prime Minister offices of India and Australia way back in 1989. So could mastering this staggering blend of macroengineering and acoustic alchemy actually save our global water infrastructure from the threats of 2026? It's an incredibly dense, provocative model, and it definitely leaves you wondering, what would it actually take to integrate such vast, cosmic concepts into the physical pipes and tankies of our modern world to secure a future?